Okay, good morning class. So today we'll be solving another numerical on thin lens formula. If you don't remember thin lens formula, go back to my previous video where I've solved one numerical using a thin lens formula, and in that video I have explained about thin lens formula. And if you still have doubt with thin lens formula, you can go to your lens maker formula. At the end of the lens maker formula, we have derived thin lens formula. Okay, now coming to our question. An object of size 3 cm is placed 14 cm in front of a concave lens of focal length 21 cm. Describe the image produced by the lens. What happens if the object is moved further away from the lens? So in the question they have said you have which kind of a lens? A concave lens. This concave lens has some focal length, clear, at your primary focus f. Now what they have said that there is an object placed in front of a concave lens. This object forms an image. They have asked you to describe the image produced, clear. So in this question they have said you have a concave lens. This concave lens has some focal length f. You placed an object O, clear. This object forms a image. They have asked you to describe this image, clear. Now let us look into the details which are given in the question. An object of size 3 cm. So they have given the size of the object which is your 3 cm. Underline 3 cm. That means this object height is 3 cm. So I'll write object height equals to 3 cm. Next is placed 14 cm in front of the concave lens. They have given you the object distance, and where they have placed it, they have placed in front of the concave lens. By how much? 14 cm in front of the concave lens. That means your object distance u is how much? 14 cm. Next, they have given you the focal length of the concave lens. Underline this one. Focal length is how much? 21 cm. Focal length is 21 cm. Now they have asked you to describe the image produced. We will first deal with the first part of the question. We will first explain what kind of image is formed, where is it formed. Next we will go, after that we will go to the second part of the question. That means what happens if the object is moved further away from the lens. So in this case they have asked what is your object distance, image distance v, and your image height h2. Is it clear? So I can substitute my values. U is how much? Minus 14 centimeters. So 1 by V minus 1 by minus 14 centimeter plus 1 by F. What is F? Minus 21 centimeters. So I'll write down minus 21 here. Clear? So now this negative and negative will become positive. And this negative I can take it upwards. So 1 by V plus 1 by 14 equals to minus 1 by 21. Now this term I can take it to the right hand side of the equation. So I have 1 by V equals to minus 1 by 21 minus 1 by 14. Now what I have to do, I have to take the LCM 21 and 14. common factors for 21, 7 and 3. Common factors for 14, 7 and 2. So 7 will be the common factor and 3, 2, 6. So 7, 6 are 42. So the LCM will be 42. Clear? Now 21, 2s are 42. So I'll write down minus 2 here. Similarly, 14, 3s are 42. So I'll write down 3 here, which is minus 3. So 1 by V equals to minus 2 minus 3 divided by 42. Next, 1 by 40, I can write 1 by V equals to minus 2 and minus 3 will give me minus 5 by 42. I can take the reciprocal, so V, and this side also reciprocal, minus 42 by 5. So 5 8s are 40. Remainder 2, put a decimal, 20, 5 4s are 20. So your image distance or your image will be formed at 8.4 centimeter. And what does this negative sign means? It means that your image will be formed in which direction? From right to left, that is in front of your lens. So if you have an object which is at a distance of how much? Minus 14 centimeter. The image formed, this red line, this is the image. This image is formed in front of the concave lens. At what distance it is formed? It is formed at minus 8.4 centimeter. Is it clear? So your image will be formed at minus 8.4 centimeter. After we have calculated your image distance, next we will calculate your image height h2. Okay. We can form or we can find your image height using this formula. This formula is the linear magnification for your lens. Clear? Now in this formula, M stands for your magnification, H2 stands for your height of the image, H1 height of the object, V object distance, V image distance, U object distance. Clear? Now we know our V is minus 8.4 centimeter, F is minus 21 centimeter, U is minus 14 centimeter and H1 is 3 centimeter. We have to find our image height H2. Now next we will substitute these values in our equation. Fine. Next we will substitute these values. H1 is my 3 centimeter. Image distance V is my 8.4 centimeter. Object distance U is my minus 4 centimeter. Now minus and minus get cancelled. I have 8.4 divided by 14. I can take this 3 to the other side. So I have H2 equals to 8.4 into 14. Clear? Now 8.4 into 3 will give me 4 3s are 12. Carry over 1. 8 3s are 24. 25.2. Okay. Now 25.2 divided by 14. 14 ones are 14. Remainder 11. I put a decimal here. So 112. 14 8s are 112. So I'll write 1.8. So your image height is 1.8 centimeter. And this is positive or negative? Positive. If it is positive, it means the image is formed in the upward direction and perpendicular to the principal axis. So this is your image. This image is formed in the upward direction and perpendicular to your image. Is it clear? Fine. Now we have found out all the values. Now we will describe the image produced by the lens. Now in our case, your image distance is 8.4. What does 8.4 means? The image is formed in front of the lens. If the image is formed in front of the lens, what kind of image is it? It is a virtual image. Next, the height of the object is how much? 1.8 centimeter. Clear? The height of the image, the height of the image is how much? 1.8 centimeter. Whereas the object height is how much? Your object height is how much? 3 centimeter. Okay, who is bigger, your object height or your image height? Your object height is bigger. That means your image have got smaller. Clear? This is the object, this is the image. That means your image is smaller. So what kind of image it is formed? It is formed diminished. Clear? So therefore, what are the 2 points? The image formed is virtual and diminished in size. Clear? Therefore, the image formed is virtual and diminished in size. Is it clear? Now, the final part of the question. What happens if the object is moved further away from the lens? Now, we know our thin lens formula is 1 by V minus 1 by U equals to 1 by F, or I can write 1 by V equals to 1 by U plus 1 by F. Now, the examiner or the questioner has said, what happens if you take this object further away from the lens? If you take this object further away from the lens, which of these three quantity increases? Your object distance. If the object is moved further away from the lens, your U increases. Clear? If your U increases, this is your U. If this value increases, okay, the focal length part will remain constant. So we can ignore this part. If your U increases, what happens? 1 by U, will it increase or decrease? It will decrease. Why? It is in the denominator. So if U increases, this part decreases. Clear? If this decreases, what does it means? That this value inside the bracket will increase or decrease? It will decrease. Clear? If this thing decreases, what happens? Your image distance V will increase or decrease? It will increase. Okay, so let us just revise what I have just said now. Okay, now I have said your object distance U increases. If your object distance U increases, what happens to 1 by U? It will decrease. If 1 by U decreases, what will happen to 1 by U plus 1 by F? Will it be the same value? No, it will also decrease. If 1 by U plus 1 by F decreases, we know what is 1 by U plus 1 by F? 1 by V. So what happens to this value? This will remain the same. It will increase or it will decrease? It will decrease. So if this value decreases, what happens to V? V will increase. Is it clear? If there is any confusion, you can ask. Okay. Now, if V increases, what does this means? Earlier we have found out how much was my image distance. The image distance was 8.4 centimeter. The image distance was minus 8.4 centimeter. That means if this value increases, okay, so where it will go? It will go to 8, 9, 10, 11, 12. Answer is no. If this value increases, means it should move towards the 0. Okay, this is your number line. This is 0, this is minus 1, this is minus 2. The values which are higher than minus 2. What are the values higher than minus 2? Minus 3 and minus 4? No, it is minus 1, 0, 1, 2. Is it clear? This side of the values are higher. Similarly, if you have 0 and minus 8.4, which will be the values higher than 8.4? Your left hand side or your right hand side or your left hand side? Your left hand side. Clear? All the values which are above 8.4, let us say minus 7.4, minus 6.4, minus 5.4, minus 3.4, minus 2.4, minus 1.4, 0, 1, 2, 3, 4. These values are higher than 8.4. Clear? So this thing means it should be somewhere greater than 8.4. That means minus 7.4, minus 6.4, minus 5.4, minus 4.4, minus 3.4, minus 2.4, minus 1.4. Okay, do you understand how it's happening? 0, 1, 2. So can you see this is increasing? So if my object distance u increases, my image distance v also increases. What does this mean? If this value increases, earlier my image was at minus 8.4 centimeter. Clear? This one is 8.4 centimeter. So if your object is moved towards the left, what happens? This value decreases. So this should move towards the lens. Minus 7.4, minus 6.4, minus 5.4, minus 4.4, minus 3.4. Clear? So what do you notice is that your object, or sorry, your image, this is your image, right? This image is slowly moving towards where? It is moving towards your lens. So what is the first point? The first point is, as the object moves away from the lens, the virtual image moves toward the lens. What do you mean by this? As my object, this blue one, as my object moves away from the lens, what happens? This red line will slowly move towards your lens. Is it clear? If you have any confusion, you can ask. Okay, fine. Now we'll come to our second part. We know linear magnification equals to h2 by h1 v by u. Clear? Or I can say the height of the image, h2 is the height of the image, is equals to v by u. Image distance by object distance into h1. h1 is your object height. Clear? Now again, if the object moves away from the lens, if this object moves away from the lens, your u will increase or decrease? It will increase. So if u increases, okay, u increases, what happens to v by u? V by u will increase or decrease? It will decrease. Why? U is in the denominator. Clear? So this value will decrease. If v by u decreases, what happens to v by u into h1? This value also decreases. We know h1. h1, what does it mean? It means the height of the object. Is my height of the object changing as I'm taking it away from the lens? No. So my h1 does not changes. Clear? So it doesn't plays any role. So v by u into h1 will increase or decrease? It will decrease. If this value altogether decreases, we know. What does this means? V by u into h1 means your h2. So this is your h2. Your h2 will increase or decrease? Your h2 will decrease. Now what do you mean when you say h2 decreases? If I'll say h2 decreases means the height of the image slowly decreases. Clear? So what is the second point? As the object moves away from the lens, the image height progressively diminishes in size, which means as you take the object away from the lens, your image distance, first point, it moves towards the lens. Clear? This object moves towards the lens. And what is the second point? This image height slowly decreases and it diminishes to 0. Clear? So as the object is slowly moving towards the left away from the lens, your object decreases and moves towards the lens, decreases, moves towards the lens, decreases, moves towards the lens, and finally it becomes very small in size. Is it clear? So if you have any confusion, you can ask me. Okay, thank you.